Hello dears, today we want to solve some classwork about kinetic theory of matter. Also there will be some questions about Brownian motion as well. Question 1. A vertical cylinder has smooth, well-fitted piston. This is the piston. It's well-fitted so that the air here cannot escape. Weights can be added or removed from the tray on the top of the piston. This is the tray, here is the tray, here weights can be added there. State, we just mentioned what will happen. State what happens to the pressure of the air as a result of adding weights. What will happen? Surely pressure will increases. That's it, 1 mark. If he says explain why, then it's a different story. The initial pressure of the air trapped, it was P1, this is P1, the pressure at the beginning. When weights are added, the volume decreased from, this is volume 1, 2, this is volume 2. Now the temperature does not change, and we said there is a rule, P1 times V1 should equal P2 times V2, and we can use this equation only when the temperature is constant. So here wants now what is the final pressure. Final pressure means he wants P2. For the beginning, 1.05 times 10 to the power of 5. The volume was 860. Pressure 2, he wants to have what happened to pressure 2 times V2, which is 645. Now do the calculation. The answer will be, let me do it on my calculator. The answer will be 1.4 times 10 to the power of 5 Pascal. So this is the new pressure. Look, here the volume was 800 becomes 600, so it's decreased. So the pressure will normally increase. It was 1, becomes 1.4. Okay? Now, this is a different question. It's a challenging one. It has 4 marks. The area of the piston is this much. Calculate the weight that is added. Weight, it's a force. And the question is about pressure. So force equal pressure times area. Then why there are 4 marks there? Because he wants the pressure, the weight that will be added. So at the beginning, when the pressure was 1 and there was certain area, the area does not change. So this is A, this is the area, it does not change. So the force was 1.05 times 10 to the power of 5 times area 5 times 10 to the power of negative 3. The answer will be, let me do it please. The answer will be 525 Newton. Now after the pressure becomes P2, so after it becomes 1.4 times 10 to the power of 5 times the same area, then how much the force becomes? It becomes 700 Newton. Now, since he wants the added weight, so the weight that has been added is the difference between the two forces. So it is 700 minus 525. The answer is 175 Newton. So this is the final answer. Now, keep this in mind. Here, weights are kept as shown in figure 6.1. The temperature of the air in the cylinder is increased. Temperature is increased. What did we say about this? I want to open my notebook and show you what will happen. If you remember this notebook, we said as temperature increase, what will happen? Kinetic energy will increase, so molecules will move faster. Then there are 2 possibilities. Either the pressure will increase or the volume will increase. But if the pressure increases, the volume will stay constant. And if the volume is increasing, the pressure stays constant. Now here, he's saying temperature is increased. State what happens to the volume of the air. Since we have movable piston, then it will be pushed up, so the volume will increases. State how, if at all, how the pressure of the air changes. We said if the volume increases, then the pressure stays the same. Let me show it to you for the again. As temperature increase, volume increase, but the pressure stays the same, stays constant. Okay, now what must be done to prevent the volume change in BI? BI, this one. Yani we don't want the volume to increase. What should we do? If you don't want the volume to be increased, then add more weights. Add more weights. Now the volume change in BI is prevented. This means we added some weights. State what happens to the pressure of the air in the cylinder. What will happen? As we said before, look, here we explained it before. We said if now pressure, if the volume now is constant, then the pressure will increase. So yes, pressure increases. That's it. Now, let me go to question number 2. Question number 2 says, figure 6.1 shows a quantity of gas in a cylinder fitted with a piston, P. Piston, again, describe the motion of gas molecules. Describe motion of gas molecules. This is Brownian motion. Describe Brownian motion, 3 marks. What do you say? Since they are gas, then we say they are moving randomly. Random motion. In straight lines between collisions. Surely in all directions, all the time. This is enough, but since he said it's gas, we may say at very fast speed because we assume gas molecules are moving fast. It's okay if you don't mention this. B. The piston is now slowly. You remember when we explained slowly in our last lesson? I told you when the piston is moved slowly, then the temperature stays constant. Yes, this is what we explained before. So now, the piston is pushed slowly down to decrease the volume. The temperature stays constant. State and explain in terms of molecules what happens to the pressure. Pressure increases. This is state what will happen. Now, he doesn't want just only to state. He wants to explain. So, due to more collisions between gas molecules and the walls, as we said, this is a keyword you can't ignore it. Now, before pushing the piston down, the pressure was this much. Pushing the piston reduces the volume. Calculate the final pressure. It's again P1 times V1 equal P2 times V2. The pressure was 1 10 to the power of 5. The volume was 500. It becomes P2, but it becomes 240. So P2 now is 1 times, let me do it on my calculator. The answer will be 2.08, I will round it, times 10 to the power of 5 Pascal. You can round it to 2 significant figures, as I said here. Now, this is one of the questions that it was in our previous worksheet, but we said this was cancelled. On later we will answer it. Now it's the time to answer it. I will not answer the whole page because we did it before. Only this part we did not solve it before. We said it's later. Now, at the beginning was asking what is the pressure on a force over area. Now, a closed box contains a gas. Explain in terms of molecules how a gas exerts a pressure on the walls of the box. The answer, you may find it in our notebook. We said any gas produces a pressure due to on the container. Why? This is the answer. So instead of answering it, I will write, copy the answer from notes, page 1. Note, page 1. I show it to you. You can check it on your notebook before. Okay. Now, page number 5. It's page number 5, also question number 5. Now, figure is a design for remotely operating an electrical switch using air pressure. Oh, Ustaz, we did not study electricity. Yes, not yet. And this is not related to electricity, but look to it. There is a box, metal box. It contains air. You will read in here. And this is pipe. And here there is the switch. It's operated by pressure. How? The metal box here and the pipe, this is the pipe, contains air at normal atmospheric pressure. And the switch is off. When the pressure of the metal, when the pressure in the metal box and the pipe increase to 1.5 times the atmospheric pressure, then, by pressing down the flexible, so you have to push down on this rubber, this will increase the pressure to 1.5 times the atmospheric pressure, so the switch will comes on. Explain in terms of pressure and volume how the switch is made on. Now, we know that pressure and volume are inversely proportional. So, what are you asking, Ustaz? No, explain how the pressure has increased. When we push the rubber cover, then this decreases the volume of air, so its pressure increases. That's it, because they are inversely proportional. Now, the normal atmospheric pressure is this number. At this pressure, the volume of the box is this one. So this is the beginning, this is P1, and this is V1. Calculate the reduction. Reduction means how much the volume has been changed. That says, what is the equation? P1 times V1 equal P2 times V2. The first pressure, it was 1 times 10 to the power of 5, and the volume was 60. P2, here is P2. Do you see it? This is P2. This is P2. It's 1.5 times the atmospheric pressure. So 1.5 times, this is the atmospheric pressure, times V2, which is unknown. If you do your calculation, you will find that V2 is 40 centimeter cubed. Now, this is not the final answer because he doesn't want the new volume, not the final volume. He wants the reduction in the volume. So reduction is V1 minus V2. So what was 60, it becomes 40. So the reduction is only 20 centimeter cubed. That's it. Okay. Now, C, explain in terms of air particles why the switch may operate without the rubber cover being squashed, but when there is large rise in temperature. As we said before, as temperature, let me write like this, increases, pressure increases due to more speed of molecules, so more collisions with the walls. So more forces, so more pressure. It's enough, we don't need to, it's only 2 marks enough. Now the last question. This is maybe the hardest. Here, in addition, in an industrial process, a gas that is already at high pressure is trapped in a large cylinder, like this, high pressure cylinder. A gas by a piston. Figure 4.1 shows the gas in the cylinder. Now the piston is pushed into the cylinder. As the pressure of the gas changes, its temperature remains constant. Figure 4.1 shows how the pressure of the trapped gas depends on its volume. Now this is it. Here we have pressure and volume. The pressure is in megapascal and the volume is in meters cubed. Okay. Now, what does he want? Now here, he's asking you, okay, just give me a second. I want to try to print out this paper again. It will be easier. If it is open there. Okay. It doesn't like it's open. Here is it. Just give me a second, please. Okay. Now, describe the relation between the pressure, by the graph between the pressure and the gas and the volume it occupies. Explain the relation in terms of molecules. What is the relation? As we said before, pressure is inversely proportional to the volume. Now he wants to describe, this is the description. Now you have to explain why. We talked about this before here in our notes. Explain why, this is on page 6. Explain why as volume increases, pressure decreases. The answer, as volume increases, then the rate of collisions between gas molecules and the walls decreases, which decreases the forces on the walls, so less momentum, so less pressure. Here you can just write. Now continue from the notes, page 6. I don't want to write it, it's there, you can write it there. Now this is a challenging one. Determine the volume occupied by the gas when it is released into the atmosphere at a pressure of 0.1. He wants, what is the volume when the pressure 0.1? Let me go back to my previous page. If he wants what's the volume at 5, you do like this, you find the volume. At 10, you find the volume. At 15, you find the volume. At 2.5, you find the volume. He wants at 0.1. 0.1 is somewhere here. Somewhere here, look. There is nothing there. You can't even touch this one. So Ustaz, how can we do it? It's 2 marks. We said before, P1 times V1 equal P2 times V2. Now, he wants what is the volume when the pressure is 0.10 megapascal. Now, but we don't have not pressure 1, not volume 1. So you can go here and take any 2 values from the graph. What do you mean, Ustaz? You can say at when the, let me say here, when it is 5, how much the volume is? The volume here, 0.1, 0.2, 0.3, 0.4. So 0.04, because this is 0.10. So it's 0.04. So now, P1, look to it, P1 was Now, P1 is 5 megapascal, and this is 0.04. So P1 times, you can choose any other point. You can choose the 10, the 15, the 20. It will give you the same answer. Just only simply try to find two easy points. So 5 times 0.04, 5 times 0.04. Oh, my calculator is not working properly. So the volume here is 2. 2, what is the unit? You can check it from the graph. It's meters cubed. So 2 meters cubed. That's it. Now, an unused cylinder of the compressed gas is moved into a cold warehouse. The temperature of the gas decreases. If the temperature decreases, state what happens as temperature decreases to the motion. They become slower, right? And the pressure also decreases. That's it. Okay. I wish that you enjoyed this. I will send you the answers after I finish my recording. Good luck.